Subscribe now and click on the bell icon to never miss learning from Vedantu.
States of matter. Okay. Solid, liquid and gaseous state. We studied this in basic concepts in chemistry, correct?
Yes.
How are they classified and all this? So we are not going to into the details of all this. And this is the plasma state. Have you heard about this? Superheated gaseous state. That is in all stars and in stars especially. It is only the plasma state that changes. It is actually an atom which has lost all its electrons. Okay, that is the state, gaseous state, found at extremely high temperatures such as interiors of sun and stars. That is the plasma state. This we are not going to study, right? And this is another state of matter. This is at very high temperature. This is at very low temperature. Okay. So wherein they are going to lose their individual identity. They behave independently of each other, the atoms. They lose their identity because they are cooled to such an extent that their mobility is also restricted. They can't move, they don't have enough energy to move. So in that case, there is no interaction between them, so they behave independently. So this is Bose-Einstein condensate. When you go to higher classes, you will study more about this and this. But right now we are going to concentrate only on these, and in particular gaseous state. Okay, so that is about this. So then this we have studied, isn't it? Differences in the properties of different states of matter. Okay, parameters are intermolecular distance, intermolecular forces, shape, size. Okay, size in the sense volume it is. Definite volume. Okay, size is that. How much space it is going to occupy. Okay, so solid state, minimum intermolecular distance, they are very close to each other, particles. And liquid is between gases and solids. And the intermolecular distance is maximum in gases. Okay, that is the reason we study them to the maximum extent, because there is a lot of space between the two particles, so that if suitable force is applied, suitable conditions are there, then we can bring them closer. Okay, compress them. Okay, the compressed gas is going to do some work. This is what is, this is how the fuels work. Okay, so automobiles, compressed gas, compressor. Okay. So how much it is going to get compressed and how much it is going to expand, that is...
Even the reduced temperature right now.
Yeah, that is also in refrigerators. Okay, so that is the reason we study more about gases, because of their application in our day-to-day life. Okay, so and intermolecular forces, of course, because they are close by, there is maximum, this is intermediate, and this is minimum. Okay. However, these liquids and gases, they have got fluidity. They can move. Okay. Not like gases, but liquids do have. Okay. So that is because the intermolecular forces is not as high as the solid state, not even as low as the gaseous. It is in between. In the sense, the molecules can move, but they are not so, considered as fluids, very true. Okay, so liquid molecules are free to move, but they are not that free that they can leave the sample. They can't leave the sample. They will be there. Because of these intermolecular forces, other molecules will attract them. They will not allow them to leave. Wherever they want, they can't roam around. Fluidity is restricted in case of liquid state because of intermolecular forces. Okay. Now because of this fluidity, they take the shape of the container, but then the volume remains the same. Volume is not indefinite, it is definite in case of liquids and even in case of solids. And in case of gases, it is indefinite because they are capable of occupying all the available volume. That is the reason we have air everywhere, because of this property. Correct? That is also has got some application for the existence of life. Okay? Then coming to the shape. Shape is definite only for solid state. Liquids and gases, they take the shape of the container. So these are the various different properties which we have already done. Let us move ahead. Now our focus is more on gaseous state. Why? I told you that. Because they can be compressed. They are used to, yeah, it is possible. But actually, you know what? That can be done. Find its volume in the sense they can occupy whatever the volume which is available to them. So what we have done is, in order to compare the volume of these gases, we have set a condition, say some standard conditions, 273 Kelvin, that is 0 degrees centigrade. What is the volume occupied by 1 mole of some gas? Okay, so that is what we will be comparing. Otherwise, they will be occupying the available volume. We can't compare that, isn't it? Supposing you have got two gases, okay, both of them, one is at say 20 degrees, another one is 30 degrees centigrade. They will be occupying different volume, isn't it? 1 mole, both of them. This is also 1 mole. But bring both of them to a temperature which is 0 degrees centigrade. Cool them to 0 degrees centigrade. Okay. Then what happens? You will see both the volumes are equal. That is the meaning of this. We have been telling this. 1 mole of any gas occupies a volume of 22.4 liters. Okay. At STP, this condition has to be met. So this piston moves up and down till it attains this volume. Okay. So that is the one which we are going to compare. Right? Okay. Move ahead. Right. 1300 and correct. Okay, fine. Right. Okay, fine. I was thinking, what is that number? Right. Doesn't matter. Okay, yes. Devi Prasad, we had just started. I was speaking to Manu about the different states of matter which we have studied. Change with temperature. Okay, I will tell you that. See, these are the different states of matter. Probably you were not here when I explained this. These three things we have studied in basic concepts. Okay, solid, liquid and gaseous state. There is a plasma state which occurs only at very high temperature, especially in the interiors of sun and stars, wherein atoms, they lose all the electrons. Only the nucleus and the mobile electrons will be there. That is the plasma state. We are not going to study much about this. And the next one, this is at very high temperature, this is at very low temperature. There also they are going to lose. Yeah.
Like there's some atoms which are like very unstable, right? Which state can we call them as?
Atom which are unstable, they are in the atomic state only. They are not in the plasma state. Okay, depending upon the force of attraction between the atoms, they will be in solid, liquid and gaseous state. To attain plasma state, very high temperature is required. Normally, it is not available on the face of Earth. In some cases, some substances, when they are burnt, especially in the when you see that flame, gas flame, there to some extent you will see the plasma state. That's it. Not otherwise. Generally, it is not observed. Okay. Yeah. Bose-Einstein also at very low temperature. Okay, so that is those states. Then I will answer your question. Why the volume changes with temperature? Okay, that is the question, isn't it? That is because we are going to study the laws which is related to temperature volume relationship. Okay, Charles' law. We are going to study this. What happens is, when you increase the temperature, the molecules are going to acquire more kinetic energy. Kinetic energy is directly proportional to temperature. Temperature increases, kinetic energy also increases. So that means they will start moving very fast. Okay, and when they start moving very fast, they are going to hit the walls very fast, frequently. Pressure increases. So in that case, it pushes the piston above, so volume increases. Okay, so that is the reason. More frequently they are going to hit it. Right? We will see that when we come to those laws. Okay, this you see even in when you are boiling something, say water. If you have a lid here, don't you think the lid will start coming up? You can see that to some extent. That shows that there is increase in volume of the water vapor over there because of the temperature. Okay, that is an example for that. We will come to that, Devi Prasad. That is an interesting question. We will see that. Okay. This one I was speaking to you about. This is done, and then we have to see this. Intermolecular forces of attraction. What are the different types of intermolecular forces of attraction that we see between the molecules? Here we are not speaking about covalent bond. We are not speaking about ionic bond. Metallic bond either. Okay, so we are speaking about between the particles in a sample. Supposing you consider ammonia, NH3, and there are number of ammonia molecules in that sample. What kind of force is present between ammonia molecules? Because ammonia is a liquid. There has to be some force, some kind of force which must be operating between the molecules. That is the reason they are together. Okay, so that is a kind of force of attraction we will be speaking about. Okay, so let us take up those. We had done this when we had done this, I think in chemical bonding, I thought little bit of it we have done. Okay, polar interaction, non-polar interaction. Basically, to be very frank, this is also non-polar, not non-polar. To some extent, this is also polar interaction. Why, I will tell you. Okay, so in this case, first let us take up dipole-dipole interaction, dipole-induced dipole interaction, ion-dipole interaction. Okay, first let us take up dipole-dipole interaction. Supposing we take hydrogen, HCl, a sample of HCl. Okay, it is in the gaseous state, of course. HCl is a gas. When it is dissolved in water, then it becomes hydrochloric acid. Now, what kind of forces will be there? This molecule, there is basically a covalent bond between hydrogen and chlorine. Okay. Now, suppose we confine this to a container. This is much heavier than air. That is 35.51. Okay, 36.5. Some amount of HCl gas you can see. Okay, because although it is a gas, it moves here and there. But some of the HCl molecules must be together, isn't it? So what makes them to be together? That is this intermolecular force. What is that force? HCl, even though it is formed by the sharing of electrons, covalent bond, do we see the shared pair of electrons exactly midway between these two? Where is the electron density in this molecule? It is more towards, yes, more towards Cl. Okay, so therefore Cl end of the molecule, we say that it is slightly negative because it is more electronegative. This end of the molecule is, yes, more electropositive. So now there is a neighboring molecule, HCl molecule, okay? Don't you think it will attract? Yes. Not due to inductive effect, it is due to electronegativity difference only. We will see what is inductive effect. Okay, this is another molecule, neighboring molecule, which is present over there. Now because there is opposite polarity, this is going to attract. This is called as dipole-dipole interaction. This is a dipole, two poles, that's all. It is a polar molecule. So it has got dipoles, positive end and negative end. So dipole-dipole interaction. One end of the one dipole is going to attract the other end of the neighboring molecule. That is another dipole. That is the reason we call it as dipole-dipole interaction. Okay, so this is observed in all those molecules wherein the covalent bond formed is a polar covalent bond. Okay, when do you think a covalent bond is polar? Polar covalent bond. When do you get covalent bond, a polar covalent bond? Only when there is electronegativity difference between the atoms sharing the electrons, correct? There has to be some electronegativity difference. Then only we are going to get a polar covalent bond. In all those substances, we will see this kind of dipole-dipole interaction. That is the one which keeps the molecules together of that sample. Okay, so here the example that is given, where they have, we will see, it is here. Okay, this is the example that has been taken, hydrogen and fluorine, HF molecule. That is also a covalent compound, and for the same reason, the shared pair of electrons are more towards chlorine than towards hydrogen. So that is the reason the fluorine end of the molecule is slightly negative. Hydrogen end of the molecule is slightly positive. So therefore what happens? There is force of attraction between these two. This is also dipole-dipole interaction, but then we have a special name for this. What is that name? What kind of bonding is this? It is because of this HF is a liquid. And because this force of attraction is not possible in HCl, it is dipole-dipole interaction only, and it is in the gaseous state. What kind of bond is this? We have studied this in bonding. Hydrogen bonding, correct? Yes, very true. Hydrogen bonding. So because of hydrogen bonding, which is also a kind of dipole-dipole interaction, this HF, hydrogen fluoride, is a liquid, but HCl is a gas. This has got dipole-dipole interaction, but still it is a gas. That is because hydrogen bonding is much stronger than dipole-dipole interaction. Simple dipole. This is also dipole-dipole interaction. But what kind of dipole it is? It is the force of attraction between the hydrogen end of one molecule and the most electronegative or highly electronegative atom of the neighboring molecule. And this kind of dipole-dipole interaction, a special type of it which we call it as hydrogen bonding, is possible only between hydrogen and fluorine, nitrogen, oxygen. Only these three. No other element. That is the reason. This is the difference between these two. While taking the example, we have to be very careful. Okay. Both HCl and HF they have got dipole-dipole interaction. But hydrogen bonding, which is a special case of dipole-dipole interaction, is present in HF, not in HCl. Okay, that is the reason HF is a liquid, HCl is a gas. Okay, see the magnitude of this dipole-dipole interaction. This can make a sample.
Ma'am, but
or
in
break
HCl
it.
also hydrogen is there, right?
Hydrogen
So
is
why
there.
can't they-
Cl. See, there is a question here. Cl and oxygen both have got almost same value for electronegativity, around 3.5. Am I right?
Yes, ma'am.
In spite of that, oxygen can form hydrogen bonding with hydrogen, but Cl cannot. That is because, see the size of oxygen. Oxygen is this much, Cl is this much. Okay, that charge which is there on Cl atom is distributed over a larger area. Its density is less, charge density is very, very less. That is the reason it cannot form hydrogen bonding. Okay, hydrogen is so tiny. How it is going to form a bond? Right? Charge density is less, even though the electronegativity values are the same. Because of decreased charge density in Cl, this hydrogen bonding is not possible. Okay, it is only with this. And what kind of force you will see in HCl? Only dipole-dipole interaction. Correct?
Yes, ma'am.
Okay. So dipole-dipole, they will ask you in class examination, 11th probably, what is dipole-dipole interaction? Give an example. Okay, so electrostatic force of attraction between the neighboring molecules having permanent dipole moment. So permanent dipole moment means they must be polar, they must be having polar covalent bonds. Hence opposite poles they attract and align themselves. So because of this hydrogen bonding, a large number of molecules, they come closer, they are associated, and therefore the molecule comes to the liquid state. Okay, move ahead. Any doubt you can ask. Devi Prasad, if you have any doubt you can ask me. This mistake many children make. This HCl, they will think that there is hydrogen bonding between the molecules. There will not be. Okay. That is only the dipole-dipole interaction. Let us move ahead. Now what are the factors that affect dipole-dipole interaction? It is the magnitude of the charge. Okay. The electrostatic force of attraction between the neighboring molecules having permanent dipole moment. How much is the force of attraction depends upon the magnitude of the charge. Higher the magnitude of the charge, or if you say if the electronegativity difference is more, then the magnitude of dipole-dipole interaction is also more. Okay. So if there is no force of attraction, we can't say that. Molecules have no charge. Molecules should be non-polar and there should be no force of attraction. So that is the meaning. We have been speaking about polar covalent bonds, isn't it? And we said that there is polar ends, dipoles. They attract the opposite ones. Am I right? Like this. Minus.
Ma'am, what's that symbol over here next to the arrow?
Mu. This one. Mu dipole.
No, ma'am, near the arrow.
Here, it is proportion. Proportional. It is looking like R. It should be like.
Yes.
So mu, that is the dipole moment, is proportional to force of attraction. That is what it is. Force of attraction in turn is proportional to the magnitude of charge. Okay, how much is the charge between those two? That is depends upon that. If the electronegativity difference is more between the two bonded atoms, then more is the magnitude of the charge. Okay. If mu is proportional, it has to be equal. It cannot be like this. Okay. If mu is more, then force of attraction is more. In fact, it is the other way around. If force of attraction is more, dipole moment is also more. Okay? So, right. Let us take up this one. These 3 points. No force of attraction. Molecules have no charge. Molecules are non-polar. Okay? So that means there should be no force of attraction between non-polar molecules, like say hydrogen. Non-polar, isn't it? CO2, oxygen, bromine, in fact iodine. These are all non-polar molecules. There should be no force of attraction between those two. So therefore they can be in the gaseous state, moving wherever they want. That is true in case of hydrogen, true in case of chlorine, true in case of oxygen as well. But then we can liquefy them by applying pressure. Okay? When you liquefy them, don't you think they should come closer? When they come closer, there has to be some force of attraction, isn't it? Otherwise they can't come closer. So if they don't come closer, they cannot be liquefied. But it is possible to liquefy them. H2 liquid we do have. Liquefied oxygen, yes. Liquefied chlorine, definitely it is there. Okay? But coming to Br2, bromine, it is a liquid element only. The state of this element itself is liquid. It is a liquid non-metal. What about iodine? See, iodine is a solid. Despite the fact that it is a non-polar molecule. Okay? So that means, what is the other kind of force that is present over here, so that it is so great that it is bringing the non-polar molecules together to such an extent that it is in the solid state. Correct? Very interesting, isn't it? So let us see the other forces of attraction here. Dipole-induced dipole interaction. What is this dipole-induced dipole interaction? Let us see. Now say for example, we have water. Water has got dissolved gases, am I right? How do you know that it has got dissolved gases? Any simple activity that you have done to show that water has got gases dissolved in it. Otherwise, aquatic plants and animals, it is difficult for them to live underwater. Okay, there has to be a dissolved gas in this. How do we know that it is a simple activity, if you can tell me? Dissolved oxygen is there. Okay, and that is the reason when you boil water and leave it for some time, it gives you that some, unnatural smell. If you have observed, I think so. But if you leave it for a longer duration of time, it is going to gain back its normal state. Okay, that means whenever you aquatic plants, not aquatic plants, the water, boiled water. Okay, now here when you heat water, you must have observed this. When you heat water, you will see bubbles, isn't it? Even before it boils, even before it starts boiling, you will see some bubbles coming out. Those bubbles are nothing but dissolved gases, oxygen, nitrogen, carbon dioxide, etc. Now, because the dissolution of gases dissolve oxygen, that is true in water, very true. That is the first one. Any other activity, it is the second. This is the most observable one. When you heat water, you will see bubbles even before it starts boiling. I mean, as soon as you start heating it, you will see bubbles. Okay, so that is because all the dissolved gases will come out, because as the temperature increases, dissolution of gas decreases. Why it happens? You will study in chemical kinetics next year. Okay, so this is dissolved gases. Now, if what in oxygen has to be present with water, this is a polar molecule, this is a non-polar molecule. There has to be some force of attraction. Otherwise, it cannot be there in water, isn't it? What kind of force of attraction do we see? This dipole, induced dipole. How it happens? Let us see. Okay. So this is a polar molecule, like H2O. We have got H2O. Oxygen end of the molecule is slightly negative. This is positive. This is positive. Okay, this is a non-polar molecule like oxygen. Okay, you can take oxygen, O2. Right? Okay. Now what happens is, because this is a polar molecule, this is positive charge, there is interaction between. There are electrons even in oxygen molecule. Am I right? There are oxygen molecules. Now what happens when the molecule, that is water molecule, when this water molecule come closer to this, say for example I have got water like this, hydrogen is positive. Okay, what happens is there are electrons over here. Don't you think there will be distortion of this electron density? Now if oxygen end of the molecule comes, there is negative, that will repel. There will be force of attraction here. So there is going to be some kind of distortion of this electron density. Hydrogen end of water molecule is going to pull it. Force of attraction. So therefore, even though it is a non-polar molecule, this end of the molecule, because it is attracting, will have more charge, negative charge on this side. So this end of the molecule will be slightly negative. The other end compared to this will be slightly, even though it is very less. Okay, so that means this polar molecule is inducing polarity on a non-polar molecule. Yes or no? So correct? I will explain it. Okay, I will explain it. One second. Manav, you followed? I will explain it. Take the example of water and oxygen. Yeah. Okay. Right. Like this. Now you see. This is water molecule. Correct? This end of the molecule is negative. This end of the molecule is positive. There is oxygen molecule, which is non-polar. But this oxygen molecule, there are electrons, isn't it? There are electrons which have got negatively charged. Electrons moving about the nuclei of these two oxygen atoms, which are negatively charged. Okay? When this oxygen molecule is in the vicinity of this water molecule, the hydrogen end of the molecule is going to attract the electrons, isn't it? When it attracts the electrons, the symmetry of the electron cloud of the oxygen molecule is lost for a moment. There will be slightly more electrons on this side, because of which this end of the molecule is slightly negative, and the other end, because there are more electrons, the other end has to be positive. Isn't it? So that a momentary dipole is created in the non-polar molecule like oxygen. So when it is created, it will start. Now this will induce. This will induce an opposite polarity in the neighboring molecule. This continues. Okay, so this may have lost. This may have lost it only for a microsecond, or even less. But this will have already induced dipole in the neighboring molecules. This is what is called as induced dipole interaction. The molecule which is charged induces its polarity and produces interaction to the molecules which is uncharged. Okay. Dipole-induced dipole is an attraction between polar molecules having permanent dipole moment and a non-polar molecule having zero dipole moment. For example, when we add these two, ammonia and benzene, okay, there is this kind of intermolecular interaction that is seen, that is dipole-induced dipole. Best example is this only, dissolved oxygen. Okay, induced. Did you follow now?
Ma'am, like after the oxygen atom like loses its shape kind of thing, then what happens to the rest of the...
That will induce. I mean, it regains its immediately, but then that it will have induced polarity in the neighboring molecule. Okay, and there are a number of water molecules, they will be inducing dipoles in the oxygen molecules because of the same reason. Same process happens. Okay, this happens in case of all the dipole or polar molecules which are in contact with non-polar molecules. Okay, there will be force of attraction, induced force of attraction, we would say. Dipole and induced dipole moment. Okay?
Yes, ma'am.
Right. Devi Prasad, any doubt? It's not there. Okay. Right. Let us move ahead. Ion dipole interaction. We have done this in chemical bonding. Where do you see this? Ion dipole interaction. Where do we come across this kind of? Okay. You did not follow that? That was dipole and induced dipole. Did you follow that one? It is between the ions. And yes, do you follow that? Okay. Best example you can recall whenever this is there. Sometimes you tend to forget. You recall water and dissolved oxygen in that. You will remember this. Okay. If this kind of force of attraction is not there, none of the gases would be soluble in water. Okay. That is the one which keeps the gas molecules inside water. Right? Let us, that is correct, Mona. That is, whenever ionic compounds dissolve in polar solvent like water, this kind of attraction we will see. Ion dipole interaction. Okay? So let us see how it happens. Ions are charged species, whereas atoms are electrically neutral and they are formed by losing and gaining of electrons. For example, formation of NaCl. Na loses an electron, Cl gains an electron, Na becomes Na plus, Cl becomes Cl minus. There is force of attraction, which we call it as ionic bond. We have studied this, isn't it? This is what it is. NaCl. Yes, okay. This is cation and anion. When we put sodium chloride salt in water, this disassociates. I mean, positive and negative ions are separated. How are they separated? That is very important. So water is a polar molecule. It has got dipoles, positive end and negative end, right? So it is the second most electronegative element in the periodic table. It will pull the electrons towards itself and makes this water molecule polar. Okay, that and all we know. Now when you put NaCl in water, Na plus Cl minus ions are produced. Okay. Now see, number of water molecules will come and surround the Na plus ions like this, in such a way that the oxygen end of the water molecule is towards Na plus in all of them. Okay, and there is force of attraction between these two. And this, because there is force of attraction, energy is released. Whenever there is force of attraction, energy is released in chemistry. Okay. Similarly, with Cl minus atoms, see how they have arranged number of water molecules come closer, and they arrange around the Cl minus ions in such a way that the hydrogen end of the water molecule is closer to the R is towards the Cl minus ions. So in these two cases, what happens? Na plus ion and Cl minus ions are completely separated because of this process, which we call it as solvation or hydration. If water is the solvent, then we call it as hydration. Okay, hydration, during hydration or solvation, energy is released because there is force of attraction between the solvent molecules and the substance which is going to get dissolved there. Okay, so that is this kind of force of attraction. This is ion, which is a dipole. Okay, ion dipole. This is a dipole. This is an ion. So ion dipole interaction. So that is the name which is given. Ion dipole interaction. Okay? Yes. This is how it happens. They might ask.
So, ma'am, because of the water, only the Na and Cl split.
Yes. The water has the capacity to separate the oppositely charged ions. It also has another name, dielectric. Okay, that means which can insulate the oppositely charged ions, because of which they cannot come closer. They're separated completely. That is the reason they dissolve. NaCl doesn't dissolve in non-polar solvents like kerosene, benzene. It is not soluble because those solvents do not have the capability to separate the oppositely charged ions. They keep attracting each other. Till the time they keep attracting each other, they will not lose their identity. They will be in the solid state. Okay? That is the reason. So this solvation is also important. Phenomenon of oppositely charged ions getting surrounded by opposite end of the solvent molecule is called solvation. If the solvent is water, then it is called as hydration. Okay? Any doubt in this? You can ask.
I'm just 2 minutes writing the definition.
Yeah. Yes. Write down the definition. We spoke about one more term, lattice energy and hydration energy. Okay?
Yes.
So some solids, ionic solids, like BaSO4, it is an ionic solid, less soluble in water. Okay, that is because lattice energy in these cases is higher than solvation energy. That means the energy required to break these is much more than the energy released through solvation. Such ionic solids are not soluble in water. Okay? So there could be two things. Non-polar molecules and those ionic solids which have what? Higher lattice energy, they are not soluble in. This we studied in. Where did we study this? I think in classification of elements. Am I right? Yeah, that is true. Periodic properties. Okay? Yes.